Hello guys, today we're going to be working on 6.3 or Cramer's rule. Cramer's rule is pretty much using determinants to find the solutions to systems, 3x3s, 2x2s, etc, etc. Now first of all, you need to know how to find the determinants. Yesterday we went over finding the determinant of a 2x2 matrix. Today we're going to go over how to find the determinant of a 3x3 matrix. And also Cramer's rule, which you'll see is going to make your life way easier when you're trying to solve linear equation systems. Now again, to review, when we're going to find the determinant of a 2x2 matrix, you multiply these two elements, 1 times 2 is 2, and you subtract these two, the product of these two elements. 0 times 3 is 0, 2 minus 0 is 2. That's the determinant of this matrix. This minus this. Now when you're working on a 3x3 matrix, it's that exact same process, only done 3 times. What you do is, you take the first element on the upper left-hand side and multiply it, scalar multiplication with the other two elements. So you're gonna do a small matrix like this. That's gonna be the first number. Again, once you start visualizing, you'll see how it's gonna make more sense. You take the first element in the first column and multiply it by the determinant of the other two columns you're not using at the bottom. Then you're gonna take the middle number, and you always subtract the middle number, and you multiply it by the determinant of the bottom columns you're not using. 3 times 0, or 3, 1, 2, 0, 3, 1, 2, 0. Then I'm going to use my third element and find the determinant of the two columns again you're not using. So 4, let me actually, let's just finish this one. 4, and then the matrix I'm not using is 3 minus 6, 2, and 5. So again, once we have, and this is plus this element here, I'm sorry, I have to rewrite it using smaller numbers. So to repeat, the first element gets placed outside, and it's going to be a scalar multiplication of a 2x2 matrix formed by the bottom rows of the columns you're not using. Since I'm using the -1 outside, I'm going to be using the bottom two rows, and these two columns I'm not using here. -6, 1, 5, 0. Then it's always minus the second element, so minus -2 times the two bottom rows of the column you're not using, 3, 1, 2, and 0, plus the last element up here, 4, and then a small 2x2 matrix formed by the two bottom rows of the columns you aren't using, 3 minus 6, 2, and 5. Now, once I have that, all I have to do is find the determinant. Let's see. -6 times 0 is 0. Minus 5 times 1 is 5. And that number gets multiplied by -1. -1. And then -2 becomes 2. So I'm gonna add 2 times 3 times 0 is 0, minus 2 times 1 is 2, -2. And then plus 4 times the determinant of this matrix. 3 times 5 is 15, minus 2 times -6 is -12. 15 minus -12 turns positive. 15 plus 12 is 27. So now I'm going to add all this, and that's going to give you the determinant of your 3x3 matrix. -1 times -5 is +5, minus 4, 80, oh my God, I'm so dumb right now. 80, $108. I'm not thinking very fast today. 108, so 5 minus 4 is 1. and you add that to the 108, the determinant of the 3 by 3 matrix is 109. So again, let's do the exact same thing using letters so you can visualize it. And by the way, if you really want to find out how to find the determinant of a 3 by 3 matrix, it's in the book on page 382. So again, let's do the exact same thing using letters. The basic formula will be this times the two rows of the columns you're not using, E, F, H, I. The middle one is always minus whatever element you have here. If B were negative, it'd be minus a negative element. That's fine. I'm using this column, so I'm going to be using the outer two rows. It's always the same pattern. D, F, G, I, plus, and I always run out of room, C, D, E, G, H. Determinants multiply, determinants multiply, determinants multiply, add everything, done. That's how you find the determinant of a 3 by 3 matrix. Now, why do I need to find determinants? Because you'll see that we are able to solve linear equation systems incredibly quickly using determinants and Cramer's rule. Let's look at example 3 on page 39. They give me this system, 3x1 plus 2x2 equals 6. And they tell me negative 4x1 minus x2 equals negative 13. So what you're going to do in Cramer's rule is very simple. First, let's convert this into an augmented matrix, just the left-hand side. Okay, so this is going to turn into 3, 2, negative 4, negative 1. Now, step 1. Let's find the determinant of this matrix. 3 times negative 1 is negative 3, minus 2 times 4 is negative 8. Negative 3 minus negative 8 is negative 3 plus 8, or 5. So you write down your determinant. Your determinant is 5. Now, all you have to do for Cramer's rule, what Cramer's rule says is, let me rewrite my matrix. What Cramer's rule says is, to find the solutions to this system, all you have to do is substitute your answers for the column, find the determinant, and divide by this number. And then for the second answer, substitute the column for the second, or substitute these answers for the second column, find the determinant, and divide to find your second answer. So let's go ahead and do this problem. So step 1, I'm going to substitute the first column. Instead of 3, negative 4, I'm going to write down 6 and negative 13. And this column gets copied identically. Now I'm going to find the determinant of this new matrix. Negative 3 times 2 is negative 26. Well, let's do it in order. 6 times negative 1 is negative 6. 3 times negative 13 times 2 is negative 26. When I add these two, I get positive 20. Now, the determinants you get from the substituted matrix gets divided by the determinant of the original matrix. 20 divided by 5 is 4. That's going to be one of the solutions. Next, I'm going to plug in my column of answers on the second column and do the exact same process. So again, now, so we can visualize, this is my original matrix. I'm going to substitute the second column now for these two values. So I have 3, 4, 6, negative 13. Let's find the determinant. 3 times negative 13 is negative 39 minus 24 is 50. Did I copy? Oh no, this is a negative. Con razón. Sorry. Negative 4. Now it makes sense because it wasn't giving me the proper answer. So again, let's repeat. 3 times negative 13 is negative 39 minus negative 24. Terms positive. Negative 39 plus 24 is negative 15. The new determinant of the substituted matrix divided by the determinant of the original matrix will give you your second answer. And that's all you have to do to find your solutions. You plug them in and you'll see that it's correct. Now, when you're dealing with a 3 by 3 matrix, it's the exact same thing. You're going to find the determinant of the original matrix. You just write it down on the left-hand side somewhere. Original matrix determinant. You write it down somewhere. And then you're going to do the substitution 3 times now. You're going to have to substitute each column. And then when you get the determinant of the matrix of the new, when you get the determinant of the substituted matrix, you divide it by the determinant of the original matrix. You do it 3 times and it's going to give you the answer. It is a very long process. I recommend you practice. It's not difficult. There are many sign changes, many additions, many subtractions, and a couple of divisions. And that's going to give you your answer in a pretty straightforward way, not having to deal with elimination or substitution or none of that crazy stuff. That's it for today's class. Now, please do 11, 12, 15, 16, 17. 11, 12, 15, 16, 17. Those are all done using Cramer's rules. You might end up with fractions at the end of one. Just work with fractions. That's fine. If you have any questions, please let me know. Again, all you have to make sure you know how to find the determinant of a 2 by 2, a 3 by 3 matrix. You write down the determinant of the original matrix. You use the solutions you were given, the constants, to substitute your columns. Find the determinants of each column divided by the determinants of the original matrix. Those give you the solutions to the system. And you're done. So it was a pretty short class. Have a great day. Tomorrow, we're going to use the inverse matrix to find solutions. It's another somewhat short class, but we're going to add more subjects to it. So take care. Make sure you upload the homework before 10. Have a great day.